We're asked to find the length of this curve over the given interval. So using the formula that's derived in the textbook, it's from 0 to 2 pi of the square root of r squared. So there's r squared minus the derivative of r, which is negative a cosine theta squared. So if we rewrite this algebraically, right now that's way too hard of an integral to try to tackle. We got to simplify, we got to expand and combine like terms where we can. So if you expand this, parentheses is being squared, that's 64 minus 128 sine theta plus 64 sine squared theta. Oh, sorry, I always do that. I don't know why. This should be a plus in between, not a minus, right? I have the formula derived from the textbook. The length of a polar curve, it's r squared plus the derivative of r squared. I got in a weird habit doing that in the past, and I can't seem to break it. But so if we square this, that's 64 cosine squared theta with respect to theta. And so here, if you were to factor out a 64 from both of these terms, you're going to have 64 parentheses sine squared plus cosine squared. So that makes 1. So this whole thing is just 64. 64 plus 64 makes 128. I think we got everything else taken care of. So you can factor out a square root of 128 from this whole thing and put it on the outside. So if we do that, then we have 1 minus sine theta with respect to theta. Okay, so that's kind of a tricky integral to deal with. So I'm going to actually multiply by something that looks like the conjugate, 1 plus sine theta. And I'd actually have to think about what is the definition of a conjugate to know whether it should actually be called a conjugate. But the big idea is that we're going to multiply by 1 here in red. And I'm multiplying by the same thing, but just with the sign in the middle changed. That way, when I multiply these two things together, the middle terms will cancel out. We're going to have 1 minus sine squared. And we can use a Pythagorean identity. Okay, so this is, we're at 128 still. And now the top part of the fraction, it's this times this. And you can multiply the terms inside because they're both inside a square root. So that's going to be the square root of 1 minus sine squared theta over the square root of, wow, I don't know where this square root came from, huh? Sorry about that. That's 1 plus sine theta in the denominator. Okay, this up here is going to be cosine squared theta. Now, be careful. Whenever you use a square root to cancel out a squared, remember you're supposed to consider both the positive and the negative responses, okay? So instead of just writing cosine theta at the top, I've got to write the absolute value of cosine theta. And so we're going to have to look and think about the expression we're trying to integrate. Oops. Because we're almost ready for a nice easy u substitution. U is just going to be 1 plus sine theta. Then we'll have du in the numerator. But because we're dealing with the absolute value, we could change the limits of integration and then use that to help us. We could either double, let me see, or quadruple. Let me think here. Okay, so because of this, because when you take a square root of something being squared, you have to use absolute values. We have to only consider where cosine is going to be positive. So we should actually break this up into 3 different intervals, and the reason is because I guess you could rewrite it, make it just 2, but I think it would get a little less intuitive that way. Think about where cosine is positive. Cosine is positive in the first quadrant, and cosine is positive in the last quadrant. And since we're trying to integrate from 0 to 2 pi, there's 2 quadrants over here where it will be negative. So we want to integrate from 0 to pi over 2. And this can just be cosine theta over the square root of 1 plus sine theta. And this integration won't be hard once we do it, okay? And then I'm actually going to subtract the integral from 0 to, from pi over 2 to 3 pi over 2. And I'm subtracting because I'm only supposed to be dealing with the absolute value of cosine. So since it's negative here, subtracting the negative value that we're going to get out of this integral, it's going to give us the positive value that we need for our absolute value. And then for the last interval, we've done from 0 to pi over 2. We did from pi over 2 to 3 pi over 2. Now going from 3 pi over 2 to 2 pi, that's a positive interval for cosine, so we don't have to change the negative sign. That's cosine theta over the square root of 1 plus sine theta. And I ran out of whiteboard, so I'll move this up. So when you evaluate the first one, the other ones will be kind of quick. They're all the same, antiderivative. If you let u be 1 plus sine theta, then du is going to be cosine theta, and we have that. Okay, so we can do that antiderivative. So with all these, if we drop the limits of integration, because we're turning things in terms of u, this is u to the negative 1/2, okay, because this is u, and the square root of u means it's u to the 1/2 power, and since it's in the denominator of a fraction, that's u to the negative 1/2, okay? So that antiderivative is going to be 2u to the positive 1/2, because when we do an antiderivative, the power goes up by 1, but we need to have the 2 out front. That way, when we take a derivative, 1/2 times 2 would make 1 like it's supposed to. So for each of those integrals that we see at the top of the screen, we can, now we have the antiderivative. It's 2 square roots of 1, because this is a square root, 2 square roots of 1 plus sine theta. We can evaluate each of the limits of integration. So this is evaluated between 0 and pi over 2. And then we have another one. That we evaluate from pi over 2 to square root of, to 3 pi over 2. And then our last one, we go from 3 pi over 2 to the end of our interval. And again, we broke that up because of the square rooting a square. We had to deal with the fact that it had to be the absolute value. It had to only deal with positive values. And that's what this minus does. It takes all these values, which are going to be negative, changes it to positive on that interval. Okay, so with a little bit of mental arithmetic here, if you plug in pi over 2, that's 1 plus 1 makes 2. So this is 2 square roots of 2. And then we need to subtract that by what happens when you plug in 0. Sine of 0 is 0. 0 plus 1 is 1. So this is, that's square root of 1 times 2 makes 2. So that's the first one taken care of. Second one, if we plug in 3 pi over 2, that gives us negative 1 for sine. 1 plus negative 1 makes 0. 0 times 2 makes 0. Plug in pi over 2, 1 plus sine pi over 2. Sine pi over 2 is 1, so this makes 2 square roots of 2 in here. And then for this last one, I got the 2 taken care of. Okay. And so this last one, if you plug in 2 pi, you get out 0 for sine. So 1 plus 0 makes 1. So this is 2 when we plug in 2 pi. And then if you plug in 3 pi over 2, that gives us 0. So these cancel out. And then here, we're minusing a negative 2 square root of 2, so that's adding. So this is 4 square roots of 2. And then if I think if you simplify, if you do 128 times 2, that makes 256, which is square root of 256 is 16. So 16 times 4, this whole thing simplifies to just be 64.